Topic 10 is Chapter 10, Bloodstain Analysis. So this is another aspect of crime scene reconstruction. We've gone through all of this before. I'm not going to test you on it again, but just a review of the different parts of crime scene reconstruction, and we're going to look at how bloodstain analysis plays into that. The location, distribution, and appearance of bloodstains can be useful for crime scene reconstruction, trying to figure out the events that produce the bleeding. Surface texture is important. The stain's shape, size, and location have to be taken into account. And all of these can be used together to determine the direction, the dropping distance, and the angle of impact of a bloodstain. These are all important things to keep in mind. Surface texture is important because, in general, the harder and less porous the surface, less spatter results. The direction of travel of blood striking an object can be figured out because the pointed end of a blood stain faces the direction of travel. So the tail of the blood droplet will face the direction of travel. The angle of impact can be determined by measuring the degree of circular distortion. As the angle decreases, the stain becomes elongated. And that can be used to calculate the angle of impact. If we have a blood droplet that drops at a 90-degree angle, it's going to be completely circular in nature. If the blood droplet hits at an angle, like we said before, the little tail, here's the tail of the blood droplet, points in the direction of the blood traveling. So if we're looking at blood spatter in 2 dimensions, what we're going to find is called the area of convergence. How we do that is we draw straight lines through the long axis of individual blood stains. And then we see an area where those will come together here. That's the area of convergence. And that represents where the person was standing or sitting, their position when they were wounded. Area of origin adds a 3rd dimension to blood spatter analysis. What we're looking at here is determining the angle of impact. Once you do that, you can use string to create a 3-dimensional model, trace that backwards to show how high off the ground a wound was sustained. It's important to know the height of the person. If you're figuring out where they were wounded, it can be 2 or 3 feet off the ground that a person was wounded. That's going to be a different location on a person's body if they're 5 feet tall versus if they're 6 feet tall. Here's a picture of how the area of origin is calculated. So the direction of travel of the blood droplet is shown here. The length and the width of the blood droplet is measured, and then that angle of impact is made between the floor and the string. We're going towards the area of convergence, which is going to be some sort of a vertical upright, vertical post. The string's going to attach to that vertical post, and then we'll see how high off the ground that wound was sustained. There are many different bloodstain patterns. A shooting can leave this spatter pattern, can be forward spatter and backward spatter. Cast-off pattern is when you have a blood-covered object flinging blood in an arc on a nearby surface. You can use cast-off patterns, count the number of arcs to determine the minimum number of blows. Arterial spray spatter is kind of gross. That's when a victim is injured in the main artery or the heart, and that pattern shows large spurted stains for each time the heart pumps. So up here in the top left, these are cast-off patterns from a pipe, from a pool cue. You can see these different arcs or lines of the blood droplets. That's what you use to determine the minimum number of impacts or strikes by that object. This is the spatter pattern from a gunshot. You can see the bullet hole here in the middle. And it's almost like a fine mist of blood. So in general, the higher velocity of the impact, the more blood droplets and the smaller they are. And then here's an arterial spray. And you see the high impact blood spatter pattern with each heartbeat. Pattern created by blood coming from the mouth is called an expirated blood pattern. A void is created when an object blocks blood spatter onto a target surface or object. When an object with blood on it comes in, touches one that doesn't, this is a contact or transfer pattern. So the blood is come into contact or transferred onto another object. Different kinds of transfer can be fingerprints, handprints, footprints, footwear prints, tool prints, fabric prints in blood. Got some examples on the next slide here. Here's contact or transfer, obviously a handprint. Here's another example with a shoe mark, contact or transfer. And here, this is a void pattern. And it might not be easy to see at first, but if I draw around the outside of the void, you can see it's a meat cleaver or a butcher knife. The edges of a bloodstain will dry to the surface. There's a pattern there called skeletonization. This one was attempted to be wiped away. Didn't fully work. And then a trail pattern is a series of drops, just like it sounds. We're trailing blood. A trail pattern is a series of drops that are separate from other patterns, and they're formed by blood dripping off an object or injury. So that's usually dripping off of the weapon that's used. Documenting bloodstains is just like all the other evidence we've been talking about collecting all semester. Photographing, noting, sketching each pattern and drop of blood, accurately recording those, measuring them to try and figure out, again, area of origin and area of convergence. That's basically it with the blood spatter patterns.